One thing that we need to talk about, even though it doesn't relate exclusively to Wi-Fi or 802.11, is the MAC address. Now, the MAC address is the Media Access Control address. It's an address that exists on every network interface card. And you'll see I'm running ifconfig here on my Mac OS system. It's going to run the same way on a Linux system. If you're running on Windows, you're going to do ipconfig instead of ifconfig. And you're going to get a similar set of information regarding the network interfaces and the addresses that are associated with them. In this case, let me just pick one of these, and you can see what we're looking for is a number that looks like this. It may be referenced as Ether, which is the Ethernet address, or it may also say MAC address. Depends on your flavor of ifconfig or ipconfig. But what you're looking for is a set of number pairs or hexadecimal number pairs specifically that are separated by a colon, like we can see here on this one. It says ether 28 CF E9 49 08 67. Now that's my MAC address for this particular interface. Every interface in the world is going to have a MAC address, and they're all going to be unique, meaning that every network interface card is going to have an address that's different from every other network interface card in the world. There should never be two network interface cards with the same address unless you've done something to manipulate or alter the address that came with the card. Now, there are ways to do what we call spoofing of MAC addresses, meaning that you can change the MAC address on your system, but by default, it's really kind of burned into the firmware so that there's one address that's associated with it. Now, this is a layer 2 address, meaning that exists at layer 2 or the data link layer of the OSI model. If we were communicating on a local network, which is what we'd be doing with Wi-Fi, of course, we're on a local network, we would be using MAC addresses to communicate with one another. So let me just start up Wireshark here and let me show you what we're doing. And I can just stop one of these captures. You can see that we've got our source IP address and our destination IP address, and I can just pop these open. Now, in this particular case, Wireshark has done a little bit of decoding for us, and it's indicating that my destination address is an Apple and my source address is Hewlett Packard. That's because the first three number pairs identify the organization that has manufactured the network interface card. So in this case, 28 CF E9 is associated with Apple, and A4 5D 36 is associated with Hewlett Packard. So Wireshark has done some of that for us, but here are what we call the Ethernet 2 address, and it's how we get information from one system to another on our local network. As I said, this is absolutely true on wireless networks just as it is on wired networks, because with wireless, you're still communicating locally, meaning you haven't taken anything off your local network to get to a remote network somewhere, even if that remote network may be on a different floor of the building or even in just a different room. Once you've moved to a different layer 3 network, and you can see our layer 3 network here is 172.30.42. Anytime I try to get to a different address from an IP perspective, I'm going to transition off my local network and I'm going to start moving around at the network layer. But anytime we're talking locally, we're talking MAC addresses. The IP addresses mean absolutely nothing, and we're communicating strictly at layer 2 or the MAC address layer. And as I said, you can see here, these are our MAC addresses that we are communicating with. Now, these MAC addresses can provide some additional security to your wireless network, and we'll get into how you can use these MAC addresses to protect you in later lessons.